Hello everyone, in this video we are going to write down the isomers of C2H5N. Let us first determine the degree of unsaturation for this elemental composition to see whether it is a completely saturated elemental composition or not. Degree of unsaturation is equal to 1 plus number of carbon atoms minus number of hydrogen atoms by 2 plus number of nitrogen atoms by 2. So therefore this is equal to 1 plus 2 minus 5 by 2 plus 1 by 2. Therefore this is equal to 3 minus 2.5 plus 0.5 and therefore 3 minus 2 and that is equal to 1. So this means when we write structures we have to consider carbon-carbon double bonds, that is one possibility, or the structure can also have carbon-nitrogen double bond, that is another possibility, or it can have one ring. All these three possibilities we need to consider when we write the isomers. So let's write the isomers one by one. Number 1, we are going to write vinylamine, that is CH2 double bond CH NH2. This is vinylamine and the corresponding structure in bond line notation is 1 2 and then the NH2 group and then the double bond. Let's number it 1 2. Vinylamine is the common name, but the preferred IUPAC name is ethenamine. That's the preferred IUPAC name, ethenamine. By the way, we should not number it from here in this way, left to right, because that would be wrong, because we need to give preference to the functional group. So therefore numbering right to left is correct in this case. So both the double bond as well as the functional group is at one position and therefore ethenamine is the simplest way you can write. If you want to specify the numbers, you have to write it as eth1 1 amine, but it is not necessary. And then number 2, we are going to write its tautomer, that is, let us assume that one of the hydrogens is getting transferred here, then that would become another structure. So that is basically CH3 and then single bond CH and then double bond NH. And the same thing in bond line notation is 1 2 and then NH and then the double bond between nitrogen and carbon. The common name is ethylamine, but the IUPAC name is ethenamine. Ethenamine. That's the IUPAC name. Keep it in mind that this is not ethenamine. If you are writing ethenamine, then basically you are mentioning this structure, CH2 and then double bond C and then double bond NH. If you write ethenamine, then you basically mean this structure, not this one. So therefore ethenamine is the correct IUPAC name for this molecule. Number 3, we are going to write N-methyl methenamine, that is CH2 double bond N and then CH3, and the corresponding structure in bond line notation will be written this way. The IUPAC name for this molecule is N-methyl, because we have the methyl group connected to nitrogen, that's why N-methyl, and then methenamine. Number 4, we are going to write a cyclic structure, that is NH and then CH2, CH2, both the CH2s are connected to NH. This is a secondary amine and the corresponding structure in bond line notation would be written this way. Azacyclopropane is the systematic IUPAC name, but the preferred IUPAC name for this is aziridine. Aziridine is the preferred IUPAC name for this molecule. So we have written 4 structures and their corresponding IUPAC names. Let's discuss isomerism among these 4 molecules. 1 and 2 are tautomers, isn't it? 1 and 2 are tautomers, because one is a amine and another is a imine. How about 1 and 3? 1 and 3 are functional group isomers, because one is a amine, primary amine, and 3 is a imine, but still tautomerism is not possible between 1 and 3. So therefore 1 and 3 are functional group isomers. How about 1 and 4? 1 and 4 are ring chain isomers. Ring chain isomerism always gets the top precedence. Even though 1 is a primary amine and 4 is a secondary amine, when it comes to isomerism order, we have to follow this. Ring chain isomerism first, and then tautomers, and then functional group isomers, and then metamers, and then chain isomers, and then position isomers. This is the precedence order we follow when we talk about various isomerism. Now, how about 2 and 3? 2 and 3 are once again functional group isomers. How about 2 and 4? 2 and 4 are ring chain isomers. How about 3 and 4? 3 and 4 are also ring chain isomers. So these are the different kinds of isomerisms that are possible among these 4 molecules.